Well, hello everybody, and welcome to today's Microservices in Azure webinar. And a special warm welcome to everybody who's joining us from France and Germany, and indeed across the world. Bonjour, guten Tag. My name is Kate. I'm a member of the marketing team here at Pluralsight, and I'm your host for today's session. We have the pleasure of being joined today by Mark Heath. Mark is a renowned Microsoft MVP Pluralsight author, and for the next hour or so, he'll share his wisdom when it comes to choosing containerization or taking a serverless approach when migrating legacy applications to the cloud. But before I hand over to Mark, just a few housekeeping tips. This session is being recorded. We will send you a link in the next day or two of the recording, so please do watch out for that. And if you do encounter any technical issues, which does happen with Zoom sometimes, pop a message in the chat box and I'll help you resolve it. Or worst case, drop off the webinar, but do rejoin. That usually fixes it. And finally, this is your opportunity to ask Mark any questions. Now, how you do that is if you simply type them into the Q&A box you see at the bottom right of the screen. Type them in as you think of them during the webinar, and Mark will get to them either during the session or at the end. So let's get started. Over to you, Mark. Mark, if you'd like to get started, you're on mute.
Sorry about that. It wouldn't let me click my... Yes, it wouldn't let me click my unmute button, but thank you very much for the welcome, Kate. Really great to see so many people here. This is a really interesting topic. I hope you'll agree. And if I just get onto the title slide again, today we're looking at building microservices in Azure and whether you should go for a container-based approach or you should take a serverless approach. And so, about 5 years ago, I kind of transitioned my role a little bit to being what you might call a cloud architect. And we were starting to build software in the cloud, and that was quite an exciting transition for me to start to use some of the new services in Azure and to use some new architectural patterns. And there was a huge amount of things to learn. And if I'm honest with you, my initial experience was a feeling of being overwhelmed. But there was just so many choices, so many technologies I could use, so many architectural patterns that people were recommending, that it became very difficult to not get stuck in sort of analysis paralysis, where you're trying to work out what is the best thing to build, what is the best technology to choose. And if you look at a platform like Azure, which I'm using extensively for my day-to-day work, there are hundreds of services. This chart that you can see here is probably over a year old now, so the number of services in Azure is even higher today. And as you can see, not only are there vast numbers of services, but even in the same category, there are many choices. So if you look in the compute column, you can see that to host my application, I can choose virtual machines, or I can choose Azure App Service, or Kubernetes Service, or Azure Container Instances. And the same with databases, loads of database options, or loads of messaging options. And so there's just a lot of choice in front of you if you're planning to build microservice applications in the cloud, in a cloud platform like Azure. And likewise, even if you decide we're going to do a microservices architecture, microservices themselves still don't really constrain your options to how you're going to architect things. So you've got complete freedom to choose things like, how are your microservices going to communicate with each other? Are they going to use RESTful APIs or gRPC, or are you going to go asynchronous? You've got the freedom for individual microservices to choose their own architectural patterns. You know, some might use CQRS, some might use event sourcing. But the question we're going to focus in on today is one that arises quite early on in your journey to microservices in the cloud, and that is whether you want to use a serverless approach or whether you want to go for a more container-based approach. And that's a question that you'll ask whether you're starting a brand new greenfield microservices application, or whether you're planning to migrate from a monolith to microservices. Just bear with me one moment, because I'm going to see if I can make sure my Q&A window is still visible, so that I can see whether any of you are asking questions in the chats. Okay, so let's get started. What we're going to do to begin with in this session is look at what are containerized and serverless approaches to cloud architecture. What's the differences between them? So I'll explain what both approaches are, and we'll talk about their strengths and why you might pick one or the other. But then I want to talk about the fact that actually it doesn't even have to necessarily be a strict choice between the two. We're increasingly seeing ways to combine the strengths of both approaches. So we'll talk a bit about how we can do that. And as Kate has said, feel free to put your questions in the Q&A box on Zoom as you go along, and I'll try and keep an eye on that and make sure they're answered for you. Okay, so what do we mean by serverless? When I talk about serverless, I tend to have three main characteristics in mind. The first is that the servers are abstracted away from us. It's not that there aren't servers, obviously, in serverless, but it enables us to think less about servers. And so one of the ideas of serverless is that the cloud provider is going to be taking responsibility for all of those servers, and we're focusing much more at the application level, at the code we're writing. Secondly, another important characteristic of serverless is the way that you'll build for it. With traditional virtual machines, you're essentially renting them. So with a virtual machine in the cloud, I pick the size of virtual machine I want, and then I'll pay a certain amount per month, regardless of whether that server is really busy for the whole month or whether it's sat idle doing nothing. But my bill will be the same. Whereas with serverless, we want to be billed only while our code is actually running. And that opens the door to some really substantial cost savings. And then the third key characteristic of serverless is the idea of automatic scale out. So with a serverless platform, if your application is working really hard, experiencing high amounts of traffic, the serverless platform will automatically scale out, adding additional compute resources to help you meet that demand. And the converse is true. If your application isn't as busy, the serverless platform will remove servers. And in fact, it may even be using no servers at all at some point if your application is completely idle. And that's one of the ways that the cloud providers can offer you such significant cost savings. So what options are there for serverless on Azure? Well, if any of you have watched my Pluralsight courses, you'll know that I'm a big fan of Azure Functions. Azure Functions is kind of the premium serverless computing service on Azure, and it could be described as a functions as a service platform. And by functions as a service, what we mean is that we're providing our code in quite small units, just individual functions, which are bits of code that run in response to some kind of event. So you tell Azure Functions, when this happens, run this bit of code. And when this other thing happens, run another piece of code. Now, Azure Functions isn't the only serverless offering on Azure. There's also Logic Apps, which in some ways is a very similar idea, but it takes a graphical programming approach. So you're essentially drawing spreadsheets rather than writing code in C# or JavaScript. And another one that we'll talk about a little bit later is quite interesting. There's something called Azure Container Instances, which tries to combine some of the strengths of serverless with running containers. Now, in Azure Functions, if you're building your code, if you're building your application in a serverless style and you've decided to use Azure Functions, each function has a trigger, so something that causes it to run. And the most common trigger types are, first of all, a timer. So with Azure Functions, it's really easy to say, at midnight every night, I want you to run this function, and it will just ensure that at midnight every night that function runs. And that's actually a great example of how the consumption-based billing can really save you money, because if all you're doing is running for, let's say, a few minutes at midnight every night, you don't want to be paying for 24 hours of idle time the rest of the time. You can also use messaging. So messages in, let's say, Azure Storage Queues or Service Bus can trigger an Azure function. And this trigger really highlights the auto scale out capabilities of Azure Functions. Because what Azure Functions can do is it can notice if the queue that you're monitoring has built up a large backlog of loads of messages. And if it has, it can automatically scale out to multiple instances of the service to help you burn through that backlog much more quickly, but you're still not paying any more than you would if you were processing them all on a single server, because you're only paying for the time that each function invocation takes. Just a question here in the Q&A about the serverless billing. With Azure Functions, you are billed in gigabyte seconds. So how many seconds your function runs for, multiplied by the number of gigabytes of RAM that the server is using. And it works out a very cheap model. You even get some free gigabyte seconds every month. Another type of trigger that's really commonly used is HTTP requests. So with HTTP requests, you can essentially use that to respond to any incoming request, which allows you to build RESTful APIs with Azure Functions. And it also allows you to respond to webhooks. It's a very common use of Azure Functions to respond to webhooks from external systems, like, for example, GitHub can send webhooks when interesting things happen on your GitHub repositories. And there are loads more. You can run functions when a new blob is uploaded to blob storage, for example, or when a new document is added to Cosmos DB. And Azure Functions also comes with a whole series of bindings. And these bindings are designed to simplify connections to other cloud services. In other words, we don't want to be writing lots of repetitive boilerplate code. I'm sure all of you are familiar that when you have to write code to connect to a database, it's just a lot of repetitive stuff that you have to do every time. And these bindings attempt to remove that for you so that the code for your function is as simple as possible and really is just about business logic and not about infrastructure. Of course, that isn't always the case. There will always be times where these bindings aren't quite what you need, so you may need to extend them in various ways. But that is one of the key strengths of the functions programming model. Now, another issue that arises when you're doing serverless is, well, that's great for my code. What about my data? Where shall I put my data? And with serverless, you tend to take advantage of the platform as a service data offerings that your cloud provider offers. And so in Azure, the 3 premium offerings are blob storage for files, SQL database if you want relational databases, and Cosmos DB if you want a document database. And could these be described as serverless? Well, in one sense, they meet the first part of serverless, where the servers are abstracted from us. We're not having to go through all of the pain of setting up and installing SQL Server ourselves and patching it to the latest version. That's all done for us. In terms of consumption-based billing and auto-scaling, blob storage very much is like that. You don't have to scale blob storage out. It's just very scalable inherently. And you're only paying for how much data you're actually storing or downloading or uploading. So if you have an empty storage account, you pay absolutely nothing. However, with SQL database and Cosmos DB, the billing models on the whole are a bit more traditional. You tend to pay or how much compute you want to reserve. So in SQL, Azure SQL, some of you will know about this. There's a couple of pricing models, one called DTUs and one called vCores. And you kind of, basically you're saying, how powerful a server do I need for my application? However, Azure have offered a serverless option for SQL, which has the ability to scale up to a more powerful server if it detects that your queries are very resource intensive, but it can also scale down to nothing and essentially put your database to sleep if it's been idle for, say, half an hour. The downside of that is that if your database has gone to sleep, then the first person to make a query to it has to wait for it to wake up again, and that might take up to a minute or so. And so that wouldn't necessarily be a very good experience if you were using Azure Functions as the backend for a public-facing website. You don't want people to be waiting that long. So even if you're going serverless, you may not always want to choose serverless offerings for all of your databases. And the same is true for Cosmos DB. There's a feature called Autopilot, which is able to scale up to more powerful request unit counts. And they have even got a serverless option now in Cosmos DB where you can get that zero cost when you're not using it option, but with some of the same caveats.
Mark, it's Kate here. Sorry to interrupt you mid-flow, but we have another question come into the Q&A box.
Okay, so yes, let's have a look at this. So are there any monitoring tools that notifies when a serverless function is stuck in an infinite loop? Yeah, so one concern that people have is, well, what if my function just gets stuck and runs forever? Will that cause me to be billed vast amounts of money? And the way Azure Functions deals with that is that the pricing model that you use by default with Azure Functions has a 5-minute time limit on all functions. So your function will be stopped after 5 minutes. And that prevents you from this kind of runaway cost thing. Now, there are some other pricing models. You can actually just use a traditional pay set amount per month pricing model with Azure Functions if you prefer, and get away from that 5-minute maximum limit. But that's kind of put there in as a protection for you. And of course, it's also possible to set up billing alerts. So if you're running in production, you'd want to have some alerts set up to make sure that you're aware if your functions are starting to misbehave and last for a long time. Okay, so that's a very brief overview of serverless. Let's talk a little bit about containers and what it might look like to build a serverless, sorry, not serverless, a microservices application with containers. So I'm sure some of you on this call will have used Docker and containers before, but just for the benefit of everyone, I'll briefly explain what they are. So containers are a way of packaging your application along with all of its dependencies. So if you've got, say, a .NET, ASP.NET Core application, your container not only has got the DLL of your .NET code's compiled C# code in it, but it's also got the .NET Core runtime. And what that means is that once you've packaged an application in a container, anything that can run containers is able to successfully run your container without the need for anything else installed other than the ability to run containers. And that means that your applications become very portable. They can run on your local development machine, they can run in an on-premises data center, and they can run in any cloud. Another really great thing about containers is that you can pack multiple containers onto a single host. So if you've got one virtual machine in the cloud and you want to run, let's say, a few microservices on it, because maybe those microservices have got fairly low memory and CPU requirements, you're able to do that. And you're able to do it in a way where they are very isolated. They won't interfere or clash with each other. And running an application in a container doesn't really add any overhead at all compared to running it directly on the host computer. It's not got large extra startup times, for example, or extra memory requirements. So it's a very efficient way of making the best use of the compute resources that you're paying for. Another really great thing about containers is that you can take advantage of a huge amount of third-party open source applications that have already been containerized for you. So if you think about caches like Redis or databases like MongoDB or Postgres, or messaging systems like RabbitMQ, all of these have already been packaged into containers. And so if you've got the ability to run containers, you can really super easily just start up instances of these third-party applications. And that can be a real benefit in a microservices architecture. And finally, containers support both Windows and Linux. Even though the majority of containers are Linux-based, because Linux-based containers tend to be smaller, more lightweight and efficient, you may well have some code that, for whatever reason, is tied to Windows. Maybe it's written in the classic .NET framework, .NET 4.7.2, for example, which is Windows only. If you want to containerize that, it's quite possible to do it. You can run on Windows. So how can we host our containers in Azure? Well, there's actually a huge number of options here. And one of my Pluralsight courses, I go through each option and I do demos of all of them. So this is kind of a super quick highlights of the ways that you can run containers. One way is, of course, you could just start a virtual machine. It could be a Windows or a Linux virtual machine with containers enabled. Or you could even run a bunch of virtual machines and install Kubernetes on them. However, that is a lot of work. And if we think about the benefits of serverless, serverless is about us not having the overhead of managing servers ourselves. So are there any other ways of running containers in Azure where we don't have to manage the servers? And the answer is yes, there's actually quite a lot. The simplest is Azure Container Instances. What you do with Azure Container Instances is you say to Azure, I've got a container image, and container images tend to be stored in what's called registries. You say, I would like to run an instance of this container, but I don't have a VM to run it on. And what Azure will do is it will just use a server that it manages to run your container, and it's got a serverless billing model. So it runs it, and when that container finishes, you stop paying. So you really are only paying while your container is running. And so that model can be very good for things like if you need to do a bunch of batch processing, where you're working through a batch of something, but then when you're done, you have no more need to be paying for compute. That can be a very attractive option. I'm sure some of you who are familiar with Azure will know about Azure App Service. Azure App Service is a really great platform for hosting web applications. And it doesn't require you to use containers at all. You can pretty much host most of the most popular web app frameworks like ASP.NET Core, PHP, Node.js, and so on. You can host them directly on App Service. However, if you do want to containerize your web apps, maybe because you're using something that isn't supported by App Service out of the box, then you can run containers on Azure Web App for Containers and take advantage of all of the other great web hosting features that that platform offers, like the ability to set up your custom domains and to configure auto scaling. And there's also Azure Service Fabric. I won't talk too much about this, but it's a very powerful microservices hosting platform and might be a particularly interesting choice if you are definitely going for the Windows-based approach. And it can host containers or non-containerized microservices. But then the one that I guess is getting most traction in the microservices space is Kubernetes. And Azure gives you a really easy way of getting started with Kubernetes in the Azure Kubernetes Service. What AKS does basically is it installs Kubernetes for you. and saves you all of the hassle. All that you need to do is just say how many worker nodes you want, so how many virtual machines you want to be available to run all of the containers. But it is fully standard Kubernetes. It's not kind of a special Microsoft build of Kubernetes. It's the full upstream open source Kubernetes. And what that means is you can buy into and take advantage of all of the vast ecosystem of added value tooling that exists on top of platforms like Kubernetes. So that was a very quick overview of these two different philosophies of building microservices in the cloud. And it raises the question of, well, which one should you choose? Should we have architectures that look like this, where we've got 100% serverless? All of our code is just these little individual Azure functions triggered by some kind of event. And all of our data and services we're using PaaS. But we could also imagine going to the opposite extreme and saying, right, everything is going to be a container. We're going to have a Kubernetes cluster, and all of our microservices will be containerized. And even things like our databases and message queuing systems, we can containerize those as well. And that's possible to do. And one of the attractions of doing that is that if you containerize absolutely everything, you've got a much more cross cloud portable solution. It's theoretically possible without too much effort to take your microservice application from Azure and run it in AWS or run it on premises. And so that might be a consideration if that's something that's really important to you. However, generally speaking, if I'm running containers in Azure, I still want to be making use where possible of the rich platform as a service offerings that Azure has to offer. And so rather than me managing and installing my own database as a container, then what I'd rather do is make use of these PaaS platforms like SQL Azure, like Cosmos DB, where it's managed for me. It deals with things like point-in-time backups and restores, much richer analytics of what's going on. So you don't necessarily need to commit to 100% containers. And by the way, I can see there's another question in the Q&A. I'm going to save that one for a little bit when I come back and talk about security. So let's just talk about what are the strengths of each approach. So first of all, what might make me pick serverless? What might make me choose a serverless approach as my primary approach? Well, one thing I think is really great about Azure Functions is that it encourages me to build in an event-driven, stateless programming model. Now, that's not to say that if I was building containers, I couldn't do that, but Azure Functions really kind of pushes me in that direction. Every function has to be event-driven, and it has to be stateless because I can't guarantee from one invocation to the next whether I'm even on the same server or not. Secondly, the bindings and integrations that come with Azure Functions enable really rapid development. Azure Functions are really great for very quickly prototyping a new idea. You've got a new idea and you're willing to work with the Azure Functions bindings, so using the services that it connects really well to, you can find that you can create something extremely quickly. It also is extremely low cost. The fact that you're only paying when your code is running and you get this monthly free grant that I mentioned, which is actually 1 million function executions and up to 400,000 gigabyte seconds, that means that while you're prototyping something and experimenting, you may not actually be billed at all. Also, the rapid and automatic scale out is a really attractive feature. The fact that I don't have to think about that at all, I just get it for free as part of what Azure Functions offers me out of the box is also very attractive. Excuse me. Are there any downsides? Well, one of the downsides that we've hinted at already is this concept of cold starts. If my function app has been idle for a while, then the first time that I try to access it, there might be a delay, let's say of up to 5 to 10 seconds before that function actually starts up. And so if you're using Azure Functions as a backing for a public-facing website, that may not be acceptable. However, there are lots of other uses of Azure Functions, things like message handling and scheduled tasks, where a cold start might not actually be a big deal at all. And we also mentioned that 5-minute timeouts limit. That may also be a blocker for some of the things that you want to do with Azure Functions. And so you'd have to work around that in various ways. And the limited coverage of the integrations. The integrations will get you so far, but you'll probably find if you're building a large enterprise application that before long, there's some things you need to do in your functions that the built-in bindings don't quite enable you to do. And so the dream of your functions being really tiny and only having business logic doesn't always quite work out in reality. Containers, one of the great strengths of containers, and this is by no means its only strength, but it's particularly good for this, is if you want to migrate a legacy service and get it containerized, it's relatively straightforward to do. Even if you've got, say, something in .NET 3, a quite old version of .NET, you can write a single Docker file for it and get it containerized and runnable in a Windows container hosting system relatively quickly. And if you compare that with the effort it would take to completely write a legacy application in Azure Functions, it's obviously much quicker to get things containerized than it is to rewrite them in a serverless way. I've also already mentioned the fact that it's really easy to adopt third-party dependencies. Because there's this vast library of excellent containerized applications, you can easily just pick the ones you would like to include in your microservices application and not be so limited by what are these services that my cloud provider is offering me. I think it's also got an excellent local developer story, particularly for microservices. With containers, you can use something called Docker Compose that makes it really easy to start up multiple containers in a single command. And so that's very attractive if you want your developers to be productive, working with lots and lots of different microservices. On the security story, the way that you would secure a Kubernetes cluster is, well, you've got some virtual machines that are part of that cluster and you can place them on a virtual network. So it's a more traditional approach to security than serverless, where every one of your function invocations is potentially running on a different virtual machine. And actually that virtual machine is potentially shared by other cloud users as well. That's not to say that serverless can't be secure, but depending on what industry you're in, they may have certain requirements that mean that the consumption-based serverless approach isn't a viable option for you. And I'll take this opportunity to just answer the question that's come in about security, which is for Azure Functions, since there's no middleware, like a conventional web API, and actually you'd be pleased to know that middleware is coming to Azure Functions, so it's not entirely true anymore. But what is the recommended way to implement authentication? Bearer token or session cookie, not using Azure AD. Typically with Azure Functions, you tend to do bearer token authentication if you want to use OAuth. However, I think it's a weakness of the Azure Functions platform that there isn't a really great built-in way to do token validation. You have to write a fair amount of code yourself. As you say, that until recently, there hasn't even been middleware. So every function invocation has to start by doing that token validation. There are a few hacky ways around that. In one of my courses, I show how to use the Azure App Services EasyAuth feature to kind of use app service to do that authentication instead of having to do it at the function level. I think there's certainly scope for Azure Functions to make authentication of incoming requests much easier. But essentially, that's how I would do it. I would use OAuth tokens, and I'd just accept the pain in my Azure function of validating those tokens. Jumping back to the benefits of containers, there is a vast ecosystem of tooling as well. And because containers have been adopted as an industry standard right across all kind of programming languages and clouds, you're seeing so many useful monitoring and deploying and security scanning add-ons to containers that if you've chosen to go for containers, then you can just make use of these really easily. Whereas for something like Azure Functions, there's probably less add-on value that you can find from elsewhere to speed up your development. On the downsides of containers, particularly when you're considering platforms like Kubernetes, it can feel an overwhelming amount to learn. Containers themselves, Docker is actually relatively simple. You could probably learn it in a day or two. But if you want to get into all of the ins and outs of how Kubernetes works, that's quite a complicated thing. And so ideally, if you want to take a development team towards microservices, you try and find a way for them to work where they don't necessarily all need to become Kubernetes experts, but they can develop on it with just a few basic Docker commands. Okay, so as I hinted at the beginning, let me just check the time. Yeah, we're doing all right for time. Do we have to necessarily choose? Do we have to choose 100% serverless or 100% containers? Or can we combine the best of both worlds and get some of the benefits of both approaches? And the answer is yes. There's absolutely nothing wrong with a hybrid architecture. You could have in the cloud, it's totally fine to have a more monolithic part of your application that's maybe running on a virtual machine, plus some bits implemented in Azure Functions, and plus some bits implemented as containers. There's absolutely nothing wrong with that. And that may actually be a viable way to start moving towards microservices. Excuse me. One example of where I've used both together is, and I did blog about this a while ago, is I was using Azure Durable Functions, which is a really cool add-on to Azure Functions that lets you create workflows in a serverless way. I think Durable Functions is excellent. Do a little quick plug. I have a whole Pluralsight course on Durable Functions. But I was using Durable Functions to implement a workflow that performed video transcoding. And video transcoding is a much longer running process and doesn't fit in the 5 minutes time execution of Azure Functions. And so what I did was I used Durable Functions as a serverless way to manage the workflow. But then when it needed to actually perform a video transcode, I started an Azure Container Instance to run a containerized version of FFmpeg. And that actually did the transcode, taking however long it took. And then when that finished, control was returned to Durable Functions. And so I got the best of both containers and serverless. I also got consumption-based pricing, because I was never paying for a virtual machine that was sat idle. I was only paying for the compute time that I was actually using. Another interesting thing, particularly if you've already decided that you're going with containers, maybe you've got a Kubernetes cluster, and so you're thinking, well, that means I can just ignore Azure Functions, they're not relevant to me. You can actually containerize an Azure Function app and run it inside a container. And that means you can run it, obviously, in Kubernetes in Azure, but you can run it in any cloud and you can run it locally. So if you like the Azure Functions programming model, there's nothing stopping you using it inside a containerized system. Now, obviously, the bit that you'd be missing if you did that is that if you run functions in Azure, Azure is monitoring how hard your functions are working and auto-scaling the amount of compute up and down depending on load levels. And that wouldn't come by default in a container because you just have one container that was always running your function out. However, there is something called CADA, an open source project that's actually now very mature. I think they just released a brand new version of it yesterday, actually. And CADA is the auto-scaling piece of Azure Functions, also containerized. So you can put CADA in your Kubernetes cluster and it can monitor the triggers for your Azure Functions. So if you've got a queue-triggered function, it can auto-scale the number of containers that are processing that queue up and down based on how many messages are in the queue. So you really can get the benefits of Azure Functions in containers. The one caveat to that is that most of the bindings and triggers that Azure Functions offers out of the box are for Azure services. And so it perhaps wouldn't make sense to run Azure Functions in AWS because all of the things that you were binding to and connecting to would still be running in Azure. So you'd be kind of talking across data centers. Unless, of course, you've made your own bindings to other services that were running in AWS. And finally, another really interesting thing with Kubernetes is that you can actually plug Azure Container Instances into a Kubernetes cluster as kind of virtual elastic compute capacity. So you can say, maybe your Kubernetes cluster has got 3 nodes and they're a bit busy because you've got a surge of extra work. You could just add another node to your AKS cluster, but with virtual nodes, you can use the elastic compute capacity of Azure Container Instances to run additional nodes very quickly on ACI. And again, it's a serverless consumption-based billing model. You only pay for those virtual nodes while they're running the containers. And then the minute you don't need the extra capacity, they completely disappear. Okay, so let me just check how we're doing for time. We've got a few more minutes. Let's talk a little bit about how you would migrate to microservices. Because I guess for many of us, we may have already built a more monolithic architecture. We've already got an application in the cloud, and we might be looking at serverless and containers and thinking, well, can they help me to move more in a microservices direction? And there are 2 main approaches to evolving in a more microservices direction. One I tend to call augmenting a monolith. So I've got my monolithic application, and then when I need to add something new to it, a new feature, a new capability, rather than just putting even more code into the monolith, I think, well, can I implement this separately as a microservice or an Azure function? And in fact, Azure functions are really great for this, because what you could do, for example, is you could make a new piece of functionality asynchronous. So your monolith just posts a message to a queue, and then your Azure function can pick up that message on the side and process it. And so Azure functions are a very lightweight way of starting to move some processing out of the giant monolith and into a serverless platform. And the advantage of it being serverless is that you're not really adding any deployment cost, or you're adding very minimal deployment cost to what you were already paying for the virtual machines that were running your monolith. But the other approach is decomposing a monolith. And it may be that your monolithic application has grown so large that you really do want to take some pieces out and extract them into microservices. And containers can be a really helpful technology for this, because what I can do with containers is that almost any legacy technology, as we've said, can be containerized. So I can easily take my existing code with minimal changes and get it running in a container. And that's much simpler, as I said, than trying to rewrite it all in a brand new serverless way. So containers can help get you a real kickstart into extracting legacy code into self-contained containerized microservices. Just a few thoughts on some of the challenges of extracting microservices. One is tight coupling and technical debt. Very often in a legacy system that's been around a long time, things aren't quite as modular as you'd like, and a lot of technical debt tends to build up. And that can really get in the way of extracting things out to microservices. So you may find, if you've got an existing monolithic application, that the best thing to do is to start just by improving its internal code structure, making things more modular, making certain modules responsible for owning certain amounts of the data, because data ownership is a very important part of microservices. In a true microservices architecture, each microservice should fully own the data in the database that it reads and writes from, and nowhere else should be accessing that data. And so if you can reorganize some of your code in your monolith into a better modularized fashion, that makes it much easier to start extracting code as microservices. One of the keys to moving in a more microservices direction is just move incrementally. You don't have to do it as one giant big project to completely split up your existing application into microservices. In fact, that's probably a bad idea to do it that way. It's much better whenever you're changing the architecture of your software to go slowly, to make a small change and then have a review point and say, maybe you add an Azure function, or you introduce a containerized microservice. And then after you've done it, you stop and you review and you say, well, did that work? Maybe you need to make some changes to your process in order to, or your tooling, in order to help adding additional microservices to be a bit smoother. And the other thing that's very important if you've decided you do want to move an existing project in a microservices direction is that you communicate vision really well. It's very important that it's not just the software architects who understand that we want to go towards serverless or containerized microservices, but that all the developers understand what the responsibilities of each microservice are, what its design philosophy is, and what the strategy is for getting there. In fact, I would say it's more than just communicating with developers. If you want to go in a microservices direction, you also need to make sure that the business understands, because microservices, you start to move to a model where you're independently deploying services, rather than with a monolith where you deploy everything all at once. With microservices, you've got the freedom to individually start releasing microservices. And that can be a big organizational change for a company that's not used to doing that. So you need to make sure that the business understands that. And also operations. If you've got an operations team who have been used to monitoring a monolith in production, they've just got one virtual machine maybe that they're monitoring, and they're looking at the logs and they're looking at its CPU and memory usage. Whereas if you go to microservices, now I've got many things that I need to monitor in the cloud. I've got many places where I need to check the logs. I've got many things where I need to check whether it's stopped running or there are problems. And so it's very important that you have centralized dashboards. And Azure is really great at that. With Azure Functions, you can connect all of your functions to what's called application insights. And that will give you a centralized place where you can see what's going on with all of them. And with containers, that's where something like Kubernetes can be very helpful in helping you to aggregate all of the logs. And there are a number of things that you can install into a Kubernetes cluster that allow you to have a centralized place where you're looking at the health and the logs for all of the containers running in your system. And I'm just going to do a little book plug here for a great book if you are interested in a bit more about the journey of going from monoliths to microservices. This book by Sam Newman that's fairly recently come out is highly recommended for that. But just looking at the time, we're coming towards the end of our time. I have got a few other slides I could show, but I'd like to give you the opportunity to ask some questions. So if you've got any questions on what I've said so far, either about containers, serverless, or the process of moving towards a more microservices architecture, then feel free to drop those into the chat, into the Q&A window now, and I'll see if I can answer them.
Mark, there is a question just come in. If you do want to run databases in containers in Azure, where is the data actually stored?
Okay, so if you've got a Kubernetes cluster and you have decided that you are going to run the databases in containers, so as I said earlier, you can just make use of Azure SQL database, but if you've decided, no, I want to containerize my databases, then you can mount what are called volumes to containers. And volumes allow containers to persistently store data. And in Azure, the two services that back those volumes are can be Azure file shares. So if you're doing Azure Container Instances, you can mount an Azure file share as a volume to a container. And if you're doing Azure Kubernetes Service, I think it's more common to use Azure disks and to mount a disk as a volume for your container. And those are great because that means that the data in my database, that's being stored in a dedicated storage service in Azure that can be geo-replicated to another region. So if I have a disaster recovery scenario and my one region of Azure goes down, I can actually recover by starting all the containers in another region and connecting them to the databases. And I've just seen another question. Logging or monitoring with serverless is the question. I guess a separate service is needed that ingests serverless logs and stores them somewhere for monitoring. Yes, you do need to log to a centralized place with serverless. One of the great things about Azure Functions is that is already happening for you. All of the logs from Azure Functions are going to application insights. And so that means that I can use application insights to not just see the logs, I can also see all of the invocations of my Azure Functions, how many times they've run, whether they were successful or not, how long they took. I can set up all kinds of monitoring based on that. So that's a really nice thing about Azure Functions, actually, that it comes out of the box with this centralized place for all of your monitoring. Of course, you may want to build additional dashboards on top of that. With durable functions, there's an open source community dashboard that someone has made that shows all of the workflows and what their current progress is. So that kind of thing is also really useful in production. If you want to have a deep insights into what all of your service functions are doing, you do definitely need that centralized place. Okay, and there's a question about AWS Cognito, which is not a service I've used. It can be configured to stop you running Lambdas if you're not authenticated. From what I understood, you have to run Azure Function and handle auth yourself, so you'll be billed even though the user is not authorized. Okay, so sorry about that. I think that was my fire alarm, but it appears to have stopped. So hopefully the house isn't burning down. So the question was about authorization. With Azure Functions, a number of the trigger types are inherently authorized. If you're running from a queue message, then you only get that if you're authorized to access the queue. But for the HTTP requests, just to give you a bit more detail, when you create an Azure function that is HTTP triggered, you can choose whether to make it anonymous, so anybody can call it, or you can protect it by a authorization code. So they have to provide in a header a secret key. And so by default, you can do that. And that means that unauthorized users just can't access. But if you need some other type of access, so when I was talking about bearer tokens, you'd set your Azure function to unauthorized, but then in your function, you would run your token validation. And the same is true with GitHub webhooks. With GitHub webhooks, you would kind of check the HMAC or the secret of the webhook payload to make sure it was authorized. And yes, that does mean that you are paying for those unauthorized calls. So that sounds like it might be an advantage of AWS if it doesn't bill you for those. And there's another question here. Are there any specific tools to help track the business case for changing between monoliths and new models? Something that tracks which transitions were easy, which ones overran, how budgets were tracked for migration effort as new TCO for execution. Okay, fire alarm going off here again. I think it's just a battery run out problem. No need to panic. But that would be really useful if there are. I'm not aware of any, but certainly you should be tracking your migration to microservices and making sure that you are actually getting the value out of it that you want to. And that book that I recommended by Sam Newman talks a lot about that. Make sure you understand why you're going to microservices and that you're checking that you're actually getting the benefits that you're supposed to. I'm just going to pop up one final slide. We might have time for a question or two, but just recommending a couple of microservice courses that I've created on Pluralsight if you want to dive deeper into this. And I've got some courses on Azure Functions and containers in Azure if you want to go deeper into those topics. But Kate, I don't know how close we are to the end. I think we probably do have time for one or two more questions.
Yes, we've got about 1 or 2 more minutes, so please do type in any questions that you may have. If not, we'll draw the webinar to a close. No more questions coming through, Mark. So, Mark, thank you very much for that. That was really informative. There was certainly a lot for us all to take in. And just a reminder, we will be emailing the recording of this webinar along with a copy of Mark's slides in the next couple of days. So you'll have the opportunity to listen to it again and to go through Mark's slide and share it with your peers as well. So I'll draw this session to an end. Mark, once again, thank you for your time today. Thank you to everybody for joining us. And we look forward to seeing you at another Pluralsight webinar soon. So stay safe. Have a great day. Thank you.
Thank you, everyone.
Bye-bye.